The manufacturers have some level of proprietary technologies in communicating between the battery and the tool. And a lot of what that does is it measures the discharge rate of the battery. And if that goes beyond the capability of the battery, it usually knows to back off or shut it down for safety. The off-brand and third-party batteries are not necessarily communicating with those safety systems.
Welcome to the Fine Homebuilding Pro Talk Podcast, a regular discussion with building industry professionals and other interesting people. This is Senior Editor Patrick McComb. Today I'm joined by electrical engineer Justin Czok. You can find the Fine Homebuilding Pro Talk Podcast and the original Fine Homebuilding Podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. Justin, first off, did I say your name correctly?
100% correctly, and thank you for not even bothering to ask beforehand. I'm impressed.
I meant to ask, honestly, and then I got into it, and I was like, I should have asked, but at least I got it right. Hey, thanks so much for being on the show.
Happy to be here.
So can you please tell me about your work currently, and then we're going to talk about your previous job in the context of Fine Homebuilding.
So by training, I'm an electrical engineer, and most of my focus is on digital circuitry and motor control. Currently, I'm working in the aerospace industry, making control actuators for Boeing, Airbus, we're a component supplier to a lot of those major brands.
And what do those things that you design do on an aircraft?
So for the most part, it is anything that could be controlled with a motor. There's the throttle things in the flight deck, so auto throttle for jets, the extension of the landing gear, the flaps, a lot of the control surfaces, and just the controls behind that.
I have so many questions. For starters, like how does one learn to do that work?
Usually it's get thrown in the pool and forget your floaties on the shore. There's so much of engineering that you learn theory in school, and it's not until day one of the real world that you're just hit with all of it. So I've been very lucky to have some really understanding teams over the years that just you build the blocks little bit by little bit, the same way you would in any other trade. And for me, I kind of feel like, I've always bridged that gap and just kept trying to add on one more Lego to that stack.
And where do you do this work and where do you live?
So I'm in Chicagoland, the northwest suburbs of, and I'm kind of living there, but we also have some property that we're building at in Indiana as well. So.
And are you a native to that part of the country?
Born and raised in the suburbs of Chicago.
Oh, cool. Can you say the company you work for presently? Is that allowed?
Sure. It's Woodward Incorporated. So they
and
are.
We'll put a link to the podcast page in case folks want to know what you make, and if they can make it out, God bless them.
Yeah, it's aerospace and industrial, so there's probably some tangential to a lot of the listeners.
Interesting. So we were introduced because you wrote into the podcast, the regular Fine Homebuilding podcast, about a discussion we had on cordless power tools and batteries in episode 519. And this was something you're knowledgeable about because you used to work at Milwaukee Power Tool.
That's correct.
Can you please talk about what you did there and how long you worked there and how you got that job?
Sure. So I spent just a little bit over 2 years there, and that one was, through the pandemic, lots of people were doing all of their remodels, so their business was booming, and they recruited me out of some of my previous roles. And I was incorporated into the outdoor power equipment group, so thinking chainsaws, string trimmers, and the expansion of that lineup. And admittedly, Milwaukee was a little bit delayed into that arena compared to some of the other brands. But my role there specifically was to help develop anything that lived in between the battery and the motor. So whether it was interfacing those two together or the external user interfaces, anything that was hardware was kind of in my purview.
It's my guess, based on the time frame we're talking about, that this stuff was largely in its infancy as far as cordless equipment, right? You were developing something that had not existed. Am I right?
There was a small bit of platforming work that occurred before I was there. They had their first string trimmer and their first chainsaw before I arrived, but a substantial portion of that growth was during my tenure, and I like to think I contributed.
So how similar is what you do now to what you did at Milwaukee?
At a high level, it's almost identical. In some sense, we're taking battery electrons and throwing them at a motor. But the difference between a consumer product where, the FCC or UL might look at it, the FAA has a much bigger say in the safety of flight, and it's a little bit more mission critical because there's not much of a service center in the air. So very similar work, just on a much bigger scale.
And can I guess you have to show them engineering and testing data to satisfy them that your motor and controls are going to work flawlessly all the time?
Yeah, there's a lot of redundancy and upsizing of componentry just to make sure that mean time between failures hits a totally different benchmark. But in both cases, the testing is pretty rigorous. A step up in the industrial and aviation sections. But we can get into that. I know we have a question later on about the actual testing procedures, and you might be surprised at just how in-depth they both go.
Yeah, I look forward to talking about that more. So did you always want to be an engineer, and did you have an interest in electronics, model railroading, or that kind of stuff?
So model
hardware?
railroading, yes.
Yeah.
But an interest in being an engineer always? No, that came later in my 20s. I was a little bit of a non-traditional student. I took several years off after high school. I was running a movie theater at the time, and I always had a passing interest in a number of things, and my lack of ability to focus kept me out of it. But when I was convinced to go back for at least an associate's degree, I just connected with a math professor who had an engineering minor, and that just kind of led me down that path. And although my family's always been around trades, it spoke to me, and I had enough of an interest and energy for it that I kept at it.
Were there other people in your life growing up who helped influence your career choice?
I like to think my dad did, but nobody had really held much of a professional. We were very much a blue-collar core family and extended family, which, was fine, but I never really felt like I fit into that. The one thing my dad always put into me is if you can learn how to do it, whether you're going to do it yourself or just know what you're asking of the people you hire, put some effort into learning it. And I kind of took that to the extreme, and now really all I do is collect hobbies and knowledge wherever I can in any segment I can.
Which creates a fantastic segue for my next question. You listen to the Fine Homebuilding podcast. Where does the interest in building and construction come from?
Building and construction, I honestly don't really know where that interest came from, but I've always been fascinated at how things go together. As you might imagine, being an engineer, there's a lot of that in me that's like the data and the analytics and the how and why versus just the manifestation of doing. And I don't know why. Maybe it was Lincoln Logs as a kid that I've always just kind of wanted to build my own house and live there. And through the many adventures of I guess, hobby collecting, I feel like I finally have the skills that I could go out and do that, and a profession that luckily affords me the opportunity to do so.
And you're building your own house now? Is that what I gathered from our little introduction?
Yeah, so I have spent the last couple of years doing gut rehabs and renovations around, an existing home. And my wife decided I have enough skills that she wants a new one, and I'm happy to provide. So past fall, we built a pole barn to serve as kind of a shop and storage space for the house build that we're planning to start in April. And I'm lucky enough to live in a county that I can do most of my work, provided I pass inspection. So I plan to.
Briefly, was that an enjoyable experience? Is it equally agonizing and enjoyable? Is it backbreaking? How would you describe what it's like to build your own stuff?
I love the challenge of, can I do it? And, I imagine you can echo this, but there's so much about home building that isn't rocket science. It's a matter of paying attention to what you're doing and just doing it right. And while I recognize I'm not efficient enough or haven't really found the tricks to make money at it, it's something I feel I can do. And although I'm scared of just the size of the thing, I've also found some enjoyment that I've been kind of putting some GoPros out and putting some of these videos on YouTube and getting feedback and encouragement from some people. And it's just something I'm really excited to do. And knowing that I'm doing a lot of it myself, I'm happy to redo some work if I have to. But it's just another thing that I can add to my list of skills to either continue performing or at least be able to have conversations and meet some interesting people in new trades.
Does your wife share your interest with hands-on activities?
Yes and no. She's more than willing to as she puts it, be the dumb labor when I need a second set of hands, and is very curious about the how and the why. But she loves to stand back and just kind of learn and let me explore. And that's kind of one of the things we do for each other. She's got her hobbies off to the side that she can be doing until I need a set of hands, and it's a really good partnership.
What is she into?
So by trade, she's an HR director, but she's also a beekeeper, a yoga instructor, and a scuba diver on the side. So
That's super cool. Do you scuba dive too?
I do. I got her into that, and we do as many things as we can to experience we did that before this game is over, and we say we wish we should have done that. That's
cool. So on to cordless power tools, and I was talking to my wife ahead of our recording today, and she's savvy enough to know, she's like, there has been tremendous strides in this technology in only 2 or 3 decades. In fact, when I started in the biz, the Milwaukee Makita 9.6 stick battery drill was in its earliest development, and boy, was that a game changer. And things have just steadily gotten better and better at an exponential pace ever since. Do you want to talk about that evolution? I mean, I'm sure you've witnessed it firsthand.
It's funny that you bring up that stick battery, because that was the first drill I ever used helping my dad do a drywall job. And
I think they're still making that in different parts of the world.
It is still being made, and some of that comes down to the cost of batteries and the fact that, for a good majority of users, it's more than capable.
Yeah, that's true.
But yeah, the exponential growth was driven in part by just the battery development itself. The chemistries within have always been able to provide enough energy. It's a matter of putting enough cells in there and still making it ergonomic. So as the chemistries have evolved and we get higher and higher energy densities, it just becomes an even more, I guess, easy to deliver technology without that cord.
And
early 2000s.
Are the tools... I'm sorry to interrupt you, but are the tools largely the same with a DC motor? I mean, is it as simple as that, or is it more complicated?
It is definitely more complicated. There are several permutations of DC motors that are out there. And if you are looking at something that is brushed, old school technology, you end up power limited per unit size or weight. So the power density of a brushed DC motor is lower. And that's one of the things that we see when we're trying to control for price, and performance goes along with price in many cases. But when you get into the newer brushless motors, there's so many electronics in there that you can tweak the parameters of those motors to be very application specific. So instead of just trying to pop the same motor and gear it for a new tool, you can actually change the ramp up in speed and the peak torque and how it actually uses that energy. And that's, I think, why we see so much proliferation at an accelerating pace, because as you get clever people to have new applications, you have even more learnings that just keeps branching out.
And you mentioned the chemistry. As I understand it, lithium ion includes a number of different chemistries. What is the specific one for power tools, or does it vary?
It varies, and that's actually one of the things you'll see under different battery types. You've got, if we're talking Milwaukee, you've got the M12, the M18, and now their MX Fuel. And inside of each of those batteries, you have a variety of different cells that you can pick from, and each cell can have a slight tweak on the chemistry, and that's going to change whether that can deliver a consistent low power over a long period of time or deliver a lot of power over a short period of time. And you can tweak that to some of your applications and even meter some of that through the tool through electronics. But there are 2 or 3 main chemistries that come into power tools, and it can vary from manufacturer to manufacturer and how they want to actually market and pair those with their tools.
Can I guess that there are various price points respective to the battery chemistries as well?
Yeah, there's price points respective to the chemistries as well as the cell size itself. So inside of a compact battery, you're using a smaller cell, where if you get to those monster 12-volt batteries, you're using something that is a little bit bigger and is capable of delivering some of that energy faster. So that's why you do see a lot of recommendations in manuals and from the manufacturers to use a specific battery at a minimum.
In my earliest introduction to this subject, I learned that there were relatively few manufacturers of the actual cells. Is that still the case?
Yes and no. There are still relatively few compared to certainly the number of power tool makers that are out there. But there is a proliferation in the manufacturers of cells as lithium ion has become more and more prevalent in more industries. You know, the 18650 cell that is used in a lot of power tool batteries was also used in some Teslas. It was used in things that are outside of EVs in general. You see them even built up into some of the portable generators that you can use on construction sites. Some of those are just big banks of small cells. And now, as we're getting more and more varieties of those cell types, we're also seeing more manufacturers. And it's becoming one of those things that's purchased in such a vast quantity that the existing manufacturing capacity just can't keep up.
So what do people do with their cordless power tools or batteries or both that is potentially damaging to them?
This is kind of Pandora's box of a question.
Oh boy, it tells me I did a good job.
Yeah. So I actually made a list here of 5 things you can do to prolong the life of your tools or batteries. So we'll get to that in a minute. But the number one mistake that I think people make is using the wrong tool or battery for the job. You know, I like to use rotary hammers as an example because people see the specs on those and they see a 5/8 or a 7/8 or a 1-inch rotary hammer. And I don't think there's really that differentiation in most people's minds of just how different the stresses are on those tools. So if you're trying to use that smaller tool on a bigger job, it might perform for a while, but the battery and the electronics aren't the only thing that can break. The gearbox or the housings are also part of that. And the one that might actually hit home for many more people is trying to use that cordless drill as a mud or mortar mixer. Your battery is going to be just fine, but your gearbox may crap out pretty quick. So that's the number one thing, is picking the right tool for the job and sizing it appropriately and matching the battery with it as well. Those compact batteries that are included with your drill driver kit, the 1.5 amp hours, just aren't going to deliver enough energy to make that tool perform the way you want it to. It's great for, you know, hanging a picture or something and putting a small screw in, but it's not really going to drive in, you know, a 6-inch lag.
Right. Or stir mud.
Or stir mud. So that's the number one thing to make your tools last longer, is to pick the right tool for the job. And if you can, buy one price point higher than you really need so that you only have to do it once. But the other thing is, marketing claims are something that can be proven one time at a minimum. So if you put too much stock in what is written on that box instead of really drilling down into the specifications of what the tool can handle, you hold that potential to shorten the life of the tool. And, you know, some of how much risk you're willing to take may depend on what segment you're in. A homeowner wanting to buy like a prosumer level tool may have different considerations than a contractor who wants that thing to work all day, every day.
And their livelihood depends on it, right? If you're not using that tool, you're wasting time.
100% agree.
So you mentioned in an email that off-brand batteries are a potential risk, and I think a lot of us have seen in our social media feeds the flaming third-party batteries. What's going on there? Is that a legitimate worry?
It is a legitimate worry. A big part of what makes the authentic batteries compatible with the tool systems is that if you look at, in fact, I've got a couple examples. When you look at the terminals on a battery, I'm hoping that this can be seen. There's
Pick
not
it up
just
a little bit. Yeah, perfect.
So there's not just a plus and a minus terminal on there that you would expect out of a DC battery, but you see several other pins in there. And what that tends to do is, actually, to the conversation on the regular podcast, the manufacturers have some level of proprietary technologies in communicating between the battery and the tool. And a lot of what that does is it measures the discharge rate of the battery. And if that goes beyond the capability of the battery, it usually knows to back off or shut it down for safety. Most of those safety concerns, especially with lithium ion, are thermal concerns. And if you get that internal cell temperature high enough, it will auto-ignite and combust. So a lot of the circuitry that's in there is meant to protect from exactly that. The off-brand and third-party batteries, while they may be compatible and fit in and deliver some number of amps of charge, they are not necessarily communicating with those safety systems. So it's very easy to overdraw and thermally exceed those batteries' limits. And that goes also with the adapters that you can buy on Amazon. It seems like a great $15 solution to put your DeWalt battery on a Makita tool, but you are defeating some of those safety systems by doing so.
And can I guess that manufacturers can offer lower cost tools? I'm not thinking about the pro brands that most of the folks who listen to this show use, but like on the more entry level stuff you see on Amazon, can I guess that one of the cost saving measures is less circuitry to protect the tool and battery from these kind of stresses?
Having never torn them apart, I can't say that for sure, but circuitry is a big part of the development cost. And there's several ways that you can manufacture safety into a tool. You can design your mechanical system to fail before your motor could overpower it, or you can put in the circuitry to protect on the battery side. And there's any number of combinations or clever solutions around it. But really, that's kind of the big differentiator, even within one brand's price points. If you go to a Makita, a Milwaukee, or DeWalt, you can get a $99 drill, $149, or you can get a $300 drill. And there is going to be a difference in the components that are used and the circuitry that's going to protect it from the expected abuses.
Like any consumer product, professional power tools have to be, have a balance of price competitiveness and durability for daily use. What are some of those tests that the companies do that you alluded to earlier? And I'll ask about your aerospace stuff just because it's interesting as well.
Yeah, so testing is a big deal. There are everything from, can we validate the claims we're putting on the box at least one time or some number of runs? So if we're talking, some sort of cutting tool, is it actually going to cut through a 4-inch log if it's a chainsaw? Or is it going to be, a pruning shear that can actually make it through that 1 inch or 1.5 inch branch that we're claiming? And it's a challenge in some environments. Outdoor power equipment's one of them, where the density of one branch versus another may validate or completely invalidate your claims, but that doesn't make it a better or worse tool. So we do try to test everything that is claimed on the box, and I presume that goes for all manufacturers, both for truth in advertising, but also for user expectation. Trying not to disappoint is a big thing. So there is some level of margin in most of those claims, but how repeatable that is, you start to wear on durability when you put something towards the edge of its design capability. But we go through testing. This actually occurs in both aerospace and in consumer tools. But full life expectancy run test. Does the motor actually run at a certain level for the number of hours that it's intended to without any sort of shorts or failures? Does the power delivery system and the controls actually keep up with it? It's very possible to melt a circuit board through a lot of these brushless motors. We are actually drawing significant amounts of current. We're exceeding 100 amps continuous in some cases. And anybody who, has ever tried to install a 100 amp circuit of any type knows how dangerous that can be. And when you're talking DC, it gets even worse. Some of these batteries now are capable of delivering in a direct short circuit well over 500 amps. So we are talking significant power levels that should be tested against, both in unexpected failures where, what happens if you drop or smash a battery, all the way to extreme run tests. And then once you go through your standard thing there, we will throw these tools or, in the case of aerospace, the assemblies into heavy vibration situations. So for power tools, you throw it in a bed that shakes around for a week at a time, simulating people who just toss a drill in the back of a pickup bed. In aerospace, the shock of landing and taking off and dealing with turbulence is a high vibration environment, and you want to make sure nothing's going to break under those circumstances. So there's a lot of just durability testing for these things that are on the edge of normal and into a little bit of the abnormal. And then in the case of some of the power tools, we then take it to the kind of crazy and extremely abnormal. If you're working with hand tools that may ever end up in a lift bucket, we'll do 20 or 30 foot drop tests. Does this thing survive some lineman who accidentally drops a tool? If we're talking a pair of shears, for instance, and it's designed for PVC. What happens when somebody says, oh, my tin snips are way over there, I got a shear in my hand? So we'll test plastic blades against metal or just extreme circumstances. In the case of some of the outdoor stuff, what happens when you're cutting on pine? You get sap everywhere. So we can pour syrup all over these things and see what happens when that dries. And just really, you will never, and no matter what consumer product segment or professional product segment you will never be able to anticipate all of the dumb things a user can do. But you try to do your best to brainstorm and test against them.
So are you in the tool business testing tools, or are you testing motors, or is it vary? Because I think you'd agree the conditions would be different if it's in a tool case versus not.
Yeah, and the answer is yes. So we will take motors, put them on an actual test stand, and we'll run them under simulated loads. And we can vary those loads up and down, make them constant. We test the electronics to failure cases. So if the electronics are designed to hold, let's say, 100 amps, what happens if something is to short out and it suddenly sees a full short circuit of the battery? Does it fail in a safe manner? And then we will do actual use case testing. We will put these things into their housings, whether they're 3D printed or actually tooled up and through production. At every stage of that development, we get, anywhere from a handful to several dozen tools, and it's, we have a handful of insiders or employees that just go use them, try to break them, see what you can do. And so it's all of the above.
So do folks, we've been talking a lot about cordless tools because I think we all agree that's where the future is, but do folks in the industry still see a place for corded tools, or are they going to go away eventually?
I think it really depends a lot on what the application is. We are at a point now where an 18-volt power tool can deliver better performance than a plug-in tool, albeit for a shorter amount of time, which is limited by the capacity of your battery. There are still some applications where either there's people who are reluctant to give up the cord because there is, honestly, a pretty significant investment in batteries if you're not there yet. Or we're still, in some cases, in the infancy where a particular brand's tool is more than just marginally better, and you might be on a different manufacturer's platform for batteries. It's an even bigger ask to switch between those. So the universal nature of being able to just plug in a cord will exist for a while, but you are going to see fewer and fewer offerings of it. We are getting to the point now where a $30 circular saw that you can plug in is not much cheaper than, a $40 or $50 circular saw from an off-brand. So if you just need to get into a battery, you can. And as those technologies come down in price, there's going to be more competent offerings, and we will see more and more people both cutting the cord and fewer manufacturers offering the cord. My experience explicitly was that we could see double-digit percentage drops in the number of corded tools sold, and in some cases, thousands of percent gains in battery.
That's crazy. I can't think of another consumer product that has had such rapid acceptance, but to me, it's obvious with the advantages we're talking about.
Yeah, I think, we do see that a little bit in some other consumer segments. Headphones are a good example. Everybody was cutting the cord for a long time, and although now there's some of us who are kind of going the opposite direction or just haven't really bought in. But yeah, there's definitely a change there. In my opinion, for the better. I don't think anybody's going to disagree with the convenience of not having to dance with that cord. But yeah, I think more and more of the world's going to go that way, and we're seeing it in vehicles now too.
I'm going to ask you about that. You must be super intrigued. Do you have an electric car?
That's an interesting discussion. I did have a Tesla for a while, and I loved it. But one of my hobbies is also being a pilot, so I traded that for a small plane. You can have anything you want. You just can't have everything you want. So I gave up the electric car for that. But no, I think it's a very promising industry segment. And now that we're seeing truck options there, if you're not trying to do a road trip with it, they're fantastic options.
What did you like about your Tesla? Was it the quiet? Was the creature comforts? Was it its looks? What did you like about it?
It was really a good exercise in understanding that life is trade-offs. The early part of it, there's absolutely that range anxiety that everybody talks about, but I was commuting with it. My daily drive was under 100 miles, and I never even thought about it. I got home, I plugged it in, and I went and had dinner, and then it was always ready for me to go anywhere. I love the fact that I could preheat it in the garage and didn't have to crack the door open. Everything was ready for me, and as we get more and more technologically savvy, you can have the car kind of prepared for what you want it to do. It knew where I was going if I wanted to link it to my calendar. And, I can see that even being an advantage for some of the trade professionals who, if they schedule
Have
out
dozens
their
of
day,
appointments, and yeah.
exactly.
Yeah.
It tells them kind of where to go, what they might need for it, and just helps them get there. So they're not thinking about that extra step of, all right, who am I seeing next? And you look at things like the new Ford Lightning and the Rivians and the Dodge Ram that was just announced, and you have some of these plug-in options as your portable generator right there with you. There's a lot of cool features that can come with it. It's just a matter of deciding for yourself, are you wanting to be a hater just because you can be, or are you open to new things? And I think that kind of comes back to the power tools. Cutting the cord is a big change, and we're all resistant to change, but there's some cool stuff if you're willing.
It's clear to me that you're curious about things, how they go together and are technologically developed. Do you think that's a typical trait of engineers?
Yeah, I think the curiosity about the why and not as much the how is very typical of a lot of industrial process engineers, electrical engineers, especially the bioengineers. When you go into some of the civil and mechanical engineers, I think they stay focused a little bit still more on the how, with a good understanding of the why. So it spans a lot of different personalities, but there is a lot of that in pretty much every engineer that I've ever been in. It stems from a significant amount of curiosity about why, but I think it's probably better to avoid the debate between the users complaining about the engineers and the engineers trying to develop for a user.
When you're out in the built environment, either locally or traveling, what do you notice about buildings? Does your interest in home building extend to commercial buildings and institutional buildings and the like?
It does. But I think my perspective has also shifted in the time since you guys have started the podcast. I think you've done a lot to educate building science-wise what is actually good practice, and especially being in Chicagoland, where the architecture here goes back significant ways and has spanned significant different types of architecture. You can see the good, the bad, and the ugly, and it's very interesting just to watch that progression over time, whether you're talking about an industrial and commercial building or even just the way you build houses in Chicago, which anybody who's ever been around Chicago or listened to questions from Chicagoland knows that there's some quirks to the way we build here.
Some nuances.
Although every city has it, but there's some unique traits out in Chicago here. But yeah, I love doing that. And then as my wife and I travel, even getting out into other parts of the country or the world, watching the way that the built environment changes based on, local customs and requirements.
So what's the best thing about being an electronics engineer?
Well, as you might have already gathered, the ability to contribute to a number of conversations and really deeply analyze the problems that are facing the world. We are increasingly dependent on silicon and the electrons moving through wires or through the air to control and power and keep everything running. So having a little bit of an inside knowledge on the way some of that's going to go or has gone, and really deciphering the quality of a technology has allowed me to make fewer purchases in the wrong direction. So it's nice to have kind of that pulse on kind of where the world is going for the next few years, and I feel comfortable at least with a little job security.
Oh, that's for sure. So, one of the things, when I ask folks in the trades this question, I ask, what is a great day doing whatever it is you do? What is a great day being an engineer for you, Justin?
This is going to sound like a cop-out answer, but it's every day. There's always a problem to solve, and they never really go away. And that's what I love doing. And I may not solve the problem in a given day, but I get to wake up every day and say, there is something for me to go and chip away at. And for me, although I'm really just spinning a motor most of the time, there are so many ways that you can apply that I don't feel like I'm in any sort of like factory work, just kind of doing the same thing over and over again. So although it's a cop-out, I get up every day and enjoy the challenge.
I'm guessing folks often have an inaccurate perception of your work, like there's this eureka moment sometimes. Am I right? I'm guessing it's not that very much.
Every once in a while you get a win that you really you smile at and then you just carry on. But the biggest misconception is that I'm an electrical engineer by trade and by training, and everybody thinks I'm an electronics technician. So whenever they have something broken, it's here, help me fix this. Although I have some knowledge of how it was designed, there are really a lot of good people out there with the hands-on skill to repair and to diagnose that may go even beyond some of the things I'm capable of. So that conflation in people's minds is sometimes frustrating, but I also like being thought of, there's always an ego to engineering.
Sure. So what part of the job would you do without if you could?
The more we develop electronics and technology, the more we live in an instant gratification world. And then that becomes the expectation on all aspects of life. And sometimes the problem does take a little bit of thought or a little bit of time. And if we could do something to separate those mentalities, it would make being in the electronics world a little bit nicer.
Do you have the same fascination as many Americans, like with the Consumer Electronics Show? Have you ever been? Do you pay attention to the stuff that's launched there?
I read some of the highlights, and I've been part of some companies that have things showcased there. But that was something I was very much into in my younger days. I'm not as old as some, but I'm older than a lot. And I recognize that I don't care if I have a new iPhone every year. I would rather buy things that are going to be meaningful for me. And most of those technologies don't come out of CES. They come out of CES from 6 years back and are now developed over time. So I rarely buy the first generation of anything, although I love being a developer on those generations.
Can you tell me about your house, what you've done to it? You mentioned that it's been a rehab largely, and then maybe talk about your new house and what that's going to be like, if you don't mind.
Sure. So this is one of those things that as I've been listening to the podcast, I tend to talk at you guys a lot through the radio like an old curmudgeon.
I think a lot of folks just yell at their audio device.
But it's also been immensely helpful. My first gut rehab was a solo endeavor. It was 1,800 square feet where everything except for the exterior wall and even some cases that was really just, can I do any of this stuff? And this was all before I had met my wife. And so she saw the outcome of that and said, hey, as you move in here, let's do this house. So I've done the facelift on the bathrooms and the kitchen and, reworked the garage and the basement. All just because I don't sit still very well.
Yeah.
And that's translated into, we decided to design our own house from the ground up. So several episodes back, you guys had a discussion on home design software, and that was one of the ones I was yelling at. It's like, it's so easy. But I did end up using one of the chief architect products, and we just sat around for a couple of weeks and drew a bunch of lines and said, how does this feel? And we came up with a plan and decided we were going to do as close as we could get to the pretty good house, although we're going to use some ICFs just because I'm doing so much of the work solo. It felt like a decent balance, even on the carbon footprint side. I'm not having 8 guys in trucks show up every day. And I can kind of do it, just walk outside, stack up a few blocks, and when it's ready, I'm hoping, I haven't run the numbers or anything, and I don't know if I'm going to, but I'm hoping that it comes out as a win for me in the end. But it's going to be relatively modest, a little 3-bedroom, 2,200 square feet. And then the barn is going to serve as my little hobby space, so I don't really need to incorporate that into the house anymore.
High-performance walls, roof, you said pretty good house. How pretty good?
So the target on the walls with the ICF, and I'm going to take the time to air seal it, They advertise an R28. I would expect probably closer to, something in the lower 20s for the walls and keeping probably around an R60 in the ceiling. I'm in climate zone 4, 5. I don't know. Those things keep changing. But our property is on the east side of Lake Michigan, so we get a lot of lake effect snow over there and have some local changes to some of those codes as a result of the snow loads. But yeah, that's kind of the goal, under 1 ACH, and do as much of that as I can myself.
Are you going to put a PV system on?
100%. Our goal is to be as close to net zero as we can be. So. And
storage, battery storage too, or just net metering, hopefully?
So luckily, working by myself, this is going to take a few years to do. I'm really curious to see some of the developments in the battery storage options. I am not completely sold on the Tesla Powerwall, particularly because of the chemistry they use there. There is some, potential thermal risk, and not that it isn't mitigated. I'm curious to see what other companies can do in the next few years with some of these systems.
How many Milwaukee 12 amp hour battery packs is that going to take to have an adequate storage battery for your house?
I discounted that as an option for a while, but maybe that's what I do, is I just have all of my batteries storing
and then up on the wall.
And then just pull one off when I need to use it. That's too many.
Do you have anything you'd like to ask or tell our audience before we go, Justin? It's been a pleasure talking to you.
Really the recommendation to just buy the right tool for the job is the one that needs to stick out there. And, just as a selfish personal plug, if anybody wants to look for the hobby collector on YouTube, you can see me building the barn up is about 99% solo. So if you want to see the trials and tribulations of an amateur trying to do that, feel free.
That's awesome. Well, unfortunately, that's all the time we have for today. Thanks for Justin Czok for joining us, and thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us however you're listening. It helps other folks find our podcast. Stay safe, everybody. Keep craft alive. Use the right tool for the job. Thanks, Justin.
Thank you.